So I hope now it is audible. Yes. So now it is audible. First one is list the properties of magnetic lines of force. List the properties of magnetic lines of force. So here you can observe magnetic field lines emerged from north and merged south. Emerged from north and merged south. So these field lines are closed loops. This field, so you can see here, this is north and south. These field lines are emerging out from north and merging at south. So these are closed loops. These are closed loops. These field lines never intersect. These field lines never intersect. If it is intersected, what happens? At the point of intersection, compass should show two directions where it is not possible. Okay, compass should show two directions where it is not possible. Understood or not? So at the point of okay. Okay, then here you can observe. List the properties of magnetic lines of force. List the properties of magnetic lines of force. They're asking. So magnetic first point is magnetic field lines emerge out from north, merge at south. These are closed loops, and these field lines never intersect. These field lines never intersect. And outside of the bar magnet, magnetic field is north to south. Inside of the bar magnetic field is south to north. Okay, so these are the points. And one more point is here. So so these field lines never intersect. So sir, what if this field lines intersect? So compass should show at a time two directions. At a time two directions should show. It is not possible, right? Compass cannot show two directions at a time. It will always show north and south direction. North and south direction, right? Yes. Okay, so normally if it is crossing like this, so at this point we can say, so along one direction we have to take and one more direction. So two directions, compass should show two directions where it is not possible. Okay, compass can show only one direction at a time, north and south direction. So it cannot be shown two directions, right? That's why these field lines never intersect. These field lines never intersect. So next one. Okay, if you want to know the magnetic field direction at particular point, so we can draw tangent. If you want to identify the magnetic field at particular point in the at particular point, okay, so this is the magnetic field. If you want to identify the magnetic field at this particular point, you have to draw the tangent to the magnetic field line. So tangent means line touches the curve at one point. Line touches the curve at one point, that is called tangent. If you draw the tangent at that particular point, we can identify the magnetic field direction. Okay, and so that's enough. So what is the show test for yeah, so what is the show test for magnetism? So the show test for magnetism is repulsion. Okay, so in the universe, every object will attract another object. Every object will attract the another object, right? So we can't see one object will attract another object will attract another object. So we can't identify, right? We can't identify. So repulsion is the show test for magnetism. Repulsion is the show test for magnetism. And so as I mentioned, if the magnetic field is leaving, that is north. Magnetic field is reaching, that is south. So here are the diagrams. So these are the diagrams they given. Okay, so you can see this is the notes. Here they mentioned this. What is this point? Magnet field is leaving. This is north. Magnet field is reaching. This is south. And here also. So here leaving north. Here it is reaching south. And here it is leaving north. And here it is also leaving north. North, north. Like that we can identify. Okay, thank you, Bharti Solanki. Thank you. Yes, I'll do it. And here you can see. So there is one question. What is the direction of magnetic field lines outside of the bar magnet? What is the magnetic field direction outside of the bar magnet? North to south. And what is indicated by crowding of magnetic lines in a given region? If more magnetic field lines are there, more crowdings, right? So magnetic field is more. If more magnetic field lines are there, then more magnetic field, more magnetic field lines. That is nothing but crowdings. Okay. So at one point more attraction will be there, more crowding will be there, then more magnetic field will be. Yes or no? Yes. So what is our question? What did you ask? So universal law of gravitation, that is capital G. So it depends on it. When the body is moving. Okay. Why don't two magnetic field lines of force? Why don't two magnetic lines of force intersect each other? So it won't intersect, as I mentioned. If it is intersect, so compass should show at a time two directions. Where it is not possible, huh? How it is possible? It cannot. It cannot, right? So two magnetic field lines never intersect. Yes. List two factors on which magnitude of magnetic field produced by current carrying straight conductor depends. So there is one question. There is one question. List two factors on which the magnitude of magnetic field produced by current carrying straight conductor depends. Point number one, strength of current. Point number two, distance from the conductor. Okay. So based on this one question is there. Near to the conductor, more magnetic field. Away from the conductor, less magnetic field. They mention the points. Okay, A, B. So at A, how the magnetic field, at B, magnetic field. Near to the conductor, magnetic field is more. Away from the conductor, magnetic field is less. Understood? Okay. So when the current is passing through the conductor, by using which rule we can identify the magnetic field direction? By using right hand thumb rule. So if the current is passing through the conductor, so if I suppose if you take current is passing along this direction, so along the current carrying conductor direction, you have to place the thumb. So curly fingers, folding fingers, wrapping fingers represent magnetic field direction. Understood? So along this direction, you have to place the thumb. So here you can take the current is passing along this direction, you have to place the thumb. Along the thumb you have to place, and the curly fingers, folding finger represent magnetic field. Okay, I hope it is very clear. Next, so what is solenoid? What is solenoid? Take a straight copper conductor. So wrap in the form of cylindrical shape, connect to the battery, current will pass through it, it act as a solenoid. So wrap in the form of here is the question. Solenoid. Take a straight copper conductor, wrap in the form of cylindrical shape, connect to the circuit, it act as a magnet. Okay, it act as a magnet. So that is a solenoid. Then yes, so there is one question, a very important question. So this, compare the magnetic behavior of straight solenoid with that of bar magnet. So as I mentioned in the solenoid, so here you can see solenoid, this is solenoid. Okay, compared to the solenoid, you can observe in the solenoid we can able to increase the magnetic field. Okay, how? By increasing strength of current and by increasing number of turns. By increasing strength of current, by increasing number of turns, we can able to increase the magnetic field. Point number one. And coming to point number two, if you increase the gap between the ring loops, so here you can see, so here you can observe, you can increase the gap between the turns. Okay, number of turns, automatically magnetic field also increases. Coming to the bar magnet, so whereas bar magnet, so magnetic field we cannot increase. In the bar magnet we can't increase the magnetic field. And poles also fixed, north pole, south pole, poles also fixed. So we can't change the magnetic poles. But in the solenoid we can interchange, we can change the poles. How? By changing the battery polarities, north south, south north, like that also we can change, right? Yes. Next, so there are many questions related to straight carrying conductor. So current is passing through the conductor. So the magnetic field will be produced. Okay. So that will become electromagnet if you place soft iron inside. So to make permanent magnets, we'll place soft iron in solenoid. So that will become electromagnet. Next, so there is one question. A student perform an experiment to study the magnetic effects. Okay. Only physics. Okay. A student perform an experiment to study the magnetic effects of current around a current carrying straight conductor with the help of magnetic compass. Okay. So a student perform an experiment to study the magnetic effects of current around a current carrying straight conductor with the help of magnetic compass. He report that the degree of deflection of magnetic compass increases when the compass is moved away from the conductor. So as I said, near to the conductor magnetic field is more, away from the conductor magnetic field will be less. Yeah, that only. Points they mention near to the point. So near to the conductor, point A they mention, point B. I said many times this question. So many times when I'm explaining, many times I repeated. Near to the conductor, magnetic field will be more. Away from the conductor, magnetic field will be less. So particularly near to the conductor, it will be concentric circles. More crowdings will be there. So like that I mentioned. Okay. So the degree of deflection of magnetic compass increases when current through the conductor increases. Definitely, this the current is more, automatically degree of deflection in the compass also will be more. List two ways increasing strength of electromagnet material electromagnet. So name the scientist who first established the connection between electricity and magnetism. Oersted, Hans Christian Oersted. Okay, so the question is, name the scientist who first established the connection between electricity and magnetism. Hans Christian Oersted, very important. So polarity, positive terminal, negative terminal battery. So if you take poles, North Pole and South Pole. What type of core is used to make an electromagnet? Soft iron. So here is one question. Here is one question. You are given two identical looking iron bars. You are given two identical looking iron bars. Just using these two two bars, how will you identify whether any or both of these bars are a magnet. So just if you bring closer to each other, then automatically we can identify it. If you bring these two bars closer to each other, whether it is a magnet or not, we can identify. North pole repel, North pole, South pole attract. Okay, South pole will attract, North pole will repel, South pole will repel, right? So by that we can identify the right? We can identify whether two magnetic poles are. State right hand thumb rule. How can you identify? So these are few questions I gathered. All questions only, no answers. State two advantages of an electromagnet or a permanent magnet. Point number one, electromagnet. So whenever we want, we can magnetize. So when current is more current sent, so more magnetic field will be produced. Huh? Okay, done. State two advantages of an electromagnet or a permanent magnet. Electromagnet. So when if the current is passing through the conductor, it acts as a magnet. When you remove the current, automatically it will not act as a magnet. Okay, and we want, if you want to increase, if you want to increase the magnetic field, we can increase by sending more current. Okay, so if you want to decrease also, we can decrease, but permanent magnet, no. And there we can change the poles in electromagnet. Okay, so north pole, south pole also we can change, but here fixed, magnetic field is fixed. North pole, south pole both are fixed. Yes. State Fleming's left hand rule. What is Fleming's left hand rule? Stretch 3 fingers of left hand, index finger, middle finger, thumb finger perpendicular to each other. Once again, index finger, middle finger, thumb finger. So index finger represent magnetic field, middle finger represent current, and thumb finger represent force acting on the conductor. Okay. Next. Name some sources of direct current. DC motor and cell or battery, right? So name 2 safety measures commonly used in electrical circuits and appliances. Name two safety measures commonly used in electrical circuits or appliances. Can you tell me what are those? Can you tell me? So one is shoes, another one is earthing. Correct? Huh? Let me know, is it correct or not? Let me know, is it correct or not? Yes, earthing, that is all earth wire. And fuse also one of the safety elements. So share to everyone, inform to everyone regarding the channel. According to our requirements, according to industrial requirements, according to ORA, we are using 220 volts. So actually automatically it shut down. Okay, so it breaks the current. MCBs, miniature circuit breakers. And coming to the fuse, automatically melt and breaks the circuit. Whenever more than required limit it goes, it melt and breaks the circuit. A small wire will be there. Okay, so in the fuse. Next one. So what is the potential? Potential of live wire 220 volts. Potential of neutral wire. Okay, once again. So when you are taking potential of live wire is 220 volts. Potential of neutral wire is 0 volts. Potential of earth wire is 0 volts. The potential difference between live wire and neutral wire is 220 volts. Prepare, that's enough. Only option is prepare. Just to prepare. Okay. So when does an electric short circuit occur? When does the electrical short circuit occur? Okay. It depends on your preparation. So I can say resources will be there around us. There are many resources. How you are utilizing it depends. Okay, whether you are utilizing for your improvement, whether you are utilizing for your development, it depends. Okay, So it completely depends on you. Okay, how we are utilizing the resources so available around us. It depends. So whether it is online or whether it is offline, so it depends on us. That's enough. Yes, when live wire and neutral wire touch each other, then heavy amount of current will be okay. It attract boss north and north, right? So that side north, that side south, this side north. If you bend it, so north and south coming closer, right? If you break it again, two pieces will be there, north and south, north and south. When you are coming, when you are bending like this, so if this like this, if you bend, so how you are bending it depends. Okay, so if you are bending like this or away or it depends. So if you are bending, then a north pole if come closer, so there must be attraction. So short circuiting means direct contact of live wire and neutral wire takes place, then heavy amount of current will be drawn from the mains, right? So overloading means high voltage appliances on at a time. Then it may lead to the short circuit. So insulation may tone, then direct contact of live and neutral wire takes place, then heavy amount of current will be drawn from the mains. Then it may lead to the short circuit also, right? Yes. Next one. So it depends on your preparation. So definitely we will work together. So definitely. So it depends on your preparation also. So actually, teacher will teach the class. What student has to do? What student has to do? Listen and practice and implement. Whatever you are preparing after practicing, you should implement in the exam. So three ways: listening, preparing, so understanding, preparing, practicing, everything. Then that must whatever you learn, you have to write in the exam, right? Okay. So in this there are three ways, but teacher can only teach, right? Teacher can only teach. Student has to do all these three things. Then you will get success. Yes, I know. Okay. So, but we will work together. Definitely. So we'll try our level best to reach. Okay. All the best and join to the club. Yeah, so today I thought two chapters. One is work and energy and power, and second one, what is the second one I thought? System of particles and rotational motion. You know? Yes. So I thought today two classes for grade 11. Tomorrow also we are discussing grade 11 topics. Okay. Name the type of current used in household supply. AC current. This question is there. And given by cell DC current. Household is AC current. Given by cell is DC current. Yeah, of course. Happy Holi to all of you. So imagine that you are sitting in a chamber with your black to one wall. So an electron beam is moving horizontally from back. See, this question I explained in the class. So same question is there. So I explained this one when I am teaching magnetic effects of electric current. This question is there. Imagine that you are sitting in a chamber with your black. So back to one wall. An electron beam is moving horizontally from back wall towards front wall. Is deflected by strong magnetic field to your right side. What is the deflection of magnetic field? They're asking that one. Okay. So by using Fleming's left hand rule. So I mentioned very clearly conventional current and electric current. So we have to take the direction of conventional current. Along the conventional current direction, you have to take, okay, na, middle finger, and so magnetic field direction. So deflection means force. So it is moving electron beam. So current is moving. Thumb is moving. Okay. So deflection towards right. Current is opposite. So in which direction? So magnetic field will be downwards. Like this, you have to understand, analyze. Okay, so like this. So actual electron beams current we have to take opposite direction, and so deflection means force. So magnetic field will be like this. Huh? What is the magnetic field in a triangle? By using right hand thumb rule, we can use. Yes. So it depends on object, rigid body, moving body. In different cases are there. Different cases are there. So it depends on how you assume. How you assume. Okay. So rigid body, moving body, like that. Okay. It happens sometimes. What is the direction of magnetic field lines outside of the bar magnet? North to south. Inside of the bar magnet, south to north. What is the frequency of AC in India? 50 Hz. State one advantage over DC. So here the question is, state one advantage of AC over DC. AC can be easily converted to DC. Okay. Yeah, direct current, alternate current. Wow, direct current and alternate current. So here is the graph. This is the graph. This is the DC. This is AC current and DC current. Yes, understood. Okay, so share to everyone, boss. Inform to everyone. We are doing so much hard work, so much content we are discussing. So ask everyone to join to the class. Okay, inform to everyone. Does magnetic field change the direction of electricity or produce electricity? So AC generator. Okay. So armature is placed in the external magnetic field. It will rotate. By that, current will be induced. Current will be generated. Point number one. And when the current is passing, magnetic field will be produced. So your question you have to check and let me know that. What is the color of live wire? Red color. Neutral wire, black color. Earth wire, green color. Okay. So thank you so much for joining and attending, listening, learning, and so do like, share, and subscribe to Student in the Brand. And this is Eva Seva sir from Student in the Brand. So do like, share, and subscribe to Student in the Brand. Inform to everyone. Ask your friends to join to the class. Share as much as possible, as many as possible. Inform to everyone. Okay. So we'll see in the next class. Thank you so much.